हम लोग क्लास 10 बोर्ड एग्ज़ाम में मैथ्स में 80/80 लाने के लिए पढ़ेंगे। स्लोली बट डेफिनेटली हम लोग ज़रूर लेकर आएंगे। इसके लिए पॉलिनोमियल चैप्टर बहुत इंपॉर्टेंट है। इसमें हम लोग सम बेसिक्स, टाइप्स ऑफ पॉलिनोमियल, डिग्री ऑफ पॉलिनोमियल्स, लीनियर, क्वाड्रेटिक, क्यूबिक पॉलिनोमियल एक्सप्रेशन को ग्राफ पेपर पर रिप्रेजेंट करना सीखेंगे। इसके लिए वीडियो को अंत तक देखें, हर एक पार्ट इम्पॉर्टेंट है और स्कोर करें 80/80। तो हम लोग वीडियो को आगे बढ़ाते हुए और हम लोग पूरा चैप्टर को सीखते हैं और इसके लिए आगे बढ़ते हैं। तो चलिए शुरू करते हैं हम लोग पॉलिनोमियल को। टुडे वी विल लर्न पॉलिनोमियल। नाउ फर्स्ट बेसिक डेफिनेशन, एन algebraic expression with one or more terms with a non-zero coefficient known as polynomial. Example, 3x square plus 2x plus 1, a symbol like xyz that can take any value known as variables. The numerical factor multiplied by a variable known as coefficient. Example, 3x cube, 3 is coefficient. Parts of the expression separated by positive negative sign known as terms. Example, x square plus 5x plus 2 have 3 terms, x square 5x2. Now exponent of polynomial must be a whole number. 0, 1, 2, 3, 4. Classification of polynomials by term. First, monomial. Polynomial having one term. Example, 5x, 3y square, etc. Now binomial. Polynomial having two terms. Example, x plus 1, 2x square minus 4x. Trinomial. Polynomial having three terms. Example, x square plus 2x plus 1. Degree of a polynomial. The degree is the highest exponent of the variable in the polynomial. Example, 3x square plus 2x plus 1. Here degree is 2 because highest exponent for variable x is 2 as x square. For multiple variables, the degree is the highest sum of exponents in a single term. Example, 5x square y cube plus 4xy. The term 5x square y cube has a degree of 2 plus 3, 5, making 5 the polynomial's degree. Now we will learn finding degree of polynomial for this single variable. First, x cube plus 3x square plus 2x plus 1. Highest exponent of a variable x is 3, so degree of polynomial is 3. Multiple variable, for example, x square y square plus 3x cube plus 4y. Here x has 3, y have degree 1, term x square y square have degree 4, given polynomial have degree 4. 7 x cube y square z. The degree of polynomial is 3 plus 2 plus 1 equal to 6. Now third, x to the power 5 minus y to the power 4 plus 8. Here term x have highest exponent 5, so degree of polynomial is 5. Now classification of polynomials by degree. First, linear, quadratic and cubic. Polynomial having degree 1 called linear, polynomial having degree 2 called quadratic, polynomial having degree 3 known as cubic. Example for linear, 2x plus 3, highest exponent of variable x is 1, so polynomial degree is 1. For quadratic example, x square plus 5x plus 6, highest exponent of variable x is 2, so polynomial degree is 2. For cubic, x cube plus 2x square minus 1, highest exponent of variable x is 3, so polynomial degree is 3. Biquadratic or quartic, fifth, quintic and sixth polynomial of n degree. Polynomial having degree 4, polynomial having degree 5 is quintic, polynomial having degree n greater than 5 is polynomial of n degree. Example, x to the power 4 minus 2x plus 3, variable x have highest exponent 4, so polynomial's degree is 4. Now for quintic, x to the power 5 plus 5x plus 6, variable x has highest exponent 5. So polynomial degree is 5. Example for n variable x to the power 7 plus 2x to the power 6 minus 1. Variable x have highest exponent 7. So polynomial degree is 7. 7. Constant polynomial. Polynomial having degree 0 is called constant polynomial. Degree 0 means variable have 0 as exponent. Real numbers are constant polynomial. 3, 6 and 7 are also polynomial without any variable, because here x to the power 0 is 1. X to the power minus 2 plus 5x plus 2 cannot be considered as polynomial, since the exponent of x is minus 2, which is not a whole number. 5 root x cannot be considered as polynomial, since the exponent of x is minus 1 by 2, which is not a whole number. Expression like root x plus 3x to the power 1 by 2 or 1 by x plus 1 cannot be considered as polynomial, because variable does not have whole number as exponent. Zeros of polynomial. For a polynomial, there could be some values of the variable for which the polynomial will be 0. These values are called zeros of polynomial. Sometimes they are also referred to as roots of the polynomial. For example, px, that is equal to x square minus 4x. Putting value of x equal to 0 or 4, we will get px equal to 0. So 0 and 4 are zeros of polynomial px. Note px is representation of polynomial, where p stands for polynomial and x for variable. In above example, p4 equal to 0, it means 0 of polynomial need not to be 0. In above example, p0 equal to 0, it means 0 of polynomial may be 0. Fundamental theorem of algebra, which state that a polynomial of degree n has exactly n zeros when counting multiplicity. In above example, degree of exponent for px is 2, number of zeros for px is 2. From above example, we concluded that a polynomial may have more than one zeros. Degree of zero polynomial is not defined. A polynomial in one variable x of degree n is an expression of form px equal to an x to the power n plus an minus 1 x to the power n minus 1 plus a1 plus a0, where n is a whole number. If all constant an minus 1, a1, a0 is 0, we get 0 polynomial, which is denoted by 0. Let px equal to 5x cube minus 2x square plus 3x minus 2. Now p1, 5 into 1 square minus 2 into 1 square plus 3 into 1 minus 2. That will be 5 minus 2 plus 3 minus 2, that will be 4. Here px at x equal to 1, not 0. So we can say that 1 is not a 0 of polynomial px. Example, if px equal to ax plus b, a not equal to 0 is a linear polynomial. How can we define a 0 of px? Solution. Finding 0 of polynomial means px equal to 0, which means ax plus b equal to 0, where a not equal to 0, ax that is equal to minus b, x equal to minus b by a. This shows that every linear polynomial has one and only one zero, means only one value of variable at which px equal to 0. Now question, verify whether 2 and 0 are zeros of the polynomial x square minus 2x. Solution, let's px equal to x square minus 2x, put x equal to 0 and 2 separately. P2 that is equal to 2 square minus 2 into 2, that will be 4 minus 4, that equal to 0. P0, 0 square minus 2 into 0, that will be 0 minus 0 equal to 0. Hence 2 and 0 are both zeros of polynomial x square minus 2x. Now we will learn graphical representation of polynomial. Geometrical meaning of zeros of a polynomial means geometrically zeros of polynomial are the points where its graph cut the x-axis. Number of zeros. So in general, a polynomial of degree n has at most n zeros. A linear polynomial has 1 zero. A quadratic polynomial has at most now 2 zeros. A cubic polynomial has at most 3 zeros. Of linear polynomial. Step 1. Determine the equation and find at least 2 or 3 ordered pair xy that satisfy the equation. For this we will taking an example, that is x plus y that is equal to 3. Now step 2, put x equal to 0 in equation x plus y equal to 3. We will get 0 plus y equal to 3, y equal to 3, and the order pair will be xy, that will be 0 and 3. Now put y equal to 0 in equation x plus y equal to 3, x plus 0 equal to 3, and we will get x equal to 3. Write order pair xy, that will be 3 0. Step 3, fill this order pair in table. First make a table with equation x and y. Now put the value of x and y and equation y equal to 3 minus x. Putting x equal to 0, we get y equal to 3. In x equal to y minus 3, putting x equal to 3, we get y equal to 0. Now plot this coordinate pair on a Cartesian plane. Now draw a straight line through the plotted point. Geometrical representation of a equation x plus y equal to 3. Take a graph, draw a vertical line and horizontal line from middle of the paper with arrow at both end. Mark horizontal line as x-axis, vertical line as y-axis, and intersection of line 0 as origin. Divide x-axis equally and mark positive numbers on right side of origin and negative number on left side of origin. Now similarly divide y-axis equally and mark negative number below origin and positive number above origin. Now circle the order pair which are written in table and draw a straight line through these coordinates. You will get x plus y equal to 3 as a straight line. Now we will see geometrical representation of quadratic polynomial. The graph of a quadratic polynomial is a parabola. It looks like a U which either open upwards or opens downward, depend upon the value of a in ax square plus bx plus c. If a is positive, then parabola open upward, and if a is negative, then it opens downward. It can cut the x-axis at 0, 1 or 2 points. Now we will see graph of a quadratic polynomial which touches the x-axis at center and a is greater than 0. So for this we take a graph paper, draw x-axis, y-axis and divide x-axis equally and y-axis equally and mark it with positive and negative numbers. Now draw a U curve passes with center. Graph of a quadratic polynomial which touches the x-axis at one point and a is greater than 0. For this take a graph and draw x-axis, y-axis. Now mark origin at a center and then equally divide x-axis and mark with a number, positive on right side, negative on left side, and then again same do with the y-axis. And now draw a parabola which touches x-axis at a point. Now graph of a quadratic polynomial that does not touches the x-axis and a is greater than 0. For this take a graph and draw x-axis and y-axis from middle of the graph paper. Now divide x-axis and y-axis equally with a equal scale. Now mark it with positive and negative number. Then draw a parabola which is open upward and not touching x-axis. It means number of zeros or root is 0. Graph of a quadratic polynomial that does not touches the x-axis. For equation y equal to x square plus 1, take a graph, then draw x-axis and y-axis, mark origin and divides x-axis and y-axis with equal scale and mark it with positive and negative number. Then after draw a parabola which is open upward, which passes through y equal to 1 but does not touch its x-axis, so number of roots is 0. Now we will take a graph of quadratic polynomial that does not touches the x-axis and a is less than 0. For this, we will take a graph paper, draw x-axis and y-axis, mark origin and divide x-axis and y-axis with a equal scale. Then after, mark it with a positive and negative number. Draw a parabola which is open downward and which does not touch the x-axis, so 0 or roots is 0. Graph of a quadratic polynomial that touches the x-axis is greater than 0 at 2 points. For this, take a graph paper and draw x-axis and y-axis and mark center at a 0. Now divide x-axis with equal scale and mark it with a positive and negative number. Similarly, divide y-axis with equal scale and mark it with a positive and negative number and draw a parabola open upward which touches x-axis at 2 points. Here touches x-axis at 2 points, so number of zeros or roots is 2. अब हम लोग कुछ पॉइंट्स देखेंगे जो पीछे जो हमने क्वाड्रेटिक पॉलिनोमियल का जो ग्राफ देखा है उसमें क्या क्या पॉइंट निकल के हैं उसको देखते हैं. तो फॉर ए पॉलिनोमियल of the form y equal to x square, if graph touches x axis then only one zero of polynomial. If graph does not touches x axis then no zero for polynomial. If graph touches 2 times x axis then there is a 2 zeros for polynomial. Now we will see graph of polynomials y equal to x to the power n. For a polynomial of the form y equal to x to the power n where n is a whole number, as n increases, the graph becomes steeper or drawn closer to the y-axis. If n is odd, the graph lies in the first and third quadrant. If n is even, the graph lies in the first and second quadrant. The graph of y equal to minus x to the power n is the reflection of the graph y equal to x to the power n on the x-axis. Now graph of a polynomial of form y equal to x cube. For this, take a graph paper and draw horizontal and vertical line. Mark it with a x-axis and y-axis. Then mark origin 0 at the center of the intersection of the lines. Now divide with a equal scale x-axis and y-axis and mark it with a negative and positive numbers. Then after draw arc, you will get y equal to x cube. Now we will see a graph of polynomial of form y equal to minus x to the power q. For this, take a graph paper, draw a vertical line, then draw a horizontal line. It will intersect, mark it is 0 and lines with x-axis and y-axis. Then divide x-axis with a equal scale and mark it with negative and positive numbers. Similarly with y-axis, mark it with a positive and negative number. Then draw an arc. You will see it is a mirror image of y equal to x to the power q. Now we will see graph of polynomial of form y equal to x square. For this, take a graph paper and draw vertical lines and horizontal lines. Mark it with x and y axis, then intersection with origin and divides x axis with equal scale and mark it with positive and negative number. Similarly do with y axis and mark it with positive and negative number. Then after draw an arc that will give y equal to x square. Now we will see graph of polynomials x cube minus 4x. List few values of y corresponding to a few values of x and make table. Now x y equal to x cube minus 4x. When we put x equal to minus 2, y equal to 0, x equal to minus 1, y equal to 3, x equal to 0, y equal to 0. And when we put x equal to 1, we get y equal to minus 3, x equal to 2, then y equal to 0. Locate the point of the table on graph paper and draw it. Here minus 2, 0 and 2 are the zeros of cubic polynomial and these are x coordinates where equation intersect. Now On a graph paper, we see that the curve or the graph cut the x-axis at 3 points, so number of roots is 3. These three coordinates on x-axis are -2, 0, 0, 0 and 2, 0. From this, we learn that if any type of curve or graph cuts or intersect x-axis at n times, then number of zeros or root for that curve will be n. इसका मतलब ये हुआ कि जितना भी टाइम्स है जो ग्राफ है या जो भी कर्व है वो एक्स एक्सिस को जितना टाइम काटेगा उतना ही जीरोज होगा। और ये जो जीरोज और रूट्स हैं जो इक्वेशन को सेटिस्फाई करेगा। तो हम लोग आज ये तक यहीं बंद करते हैं। हम लोग नेक्स्ट वीडियो में आगे देखेंगे। तब तक के लिए बाय बाय। थैंक्स फॉर वॉचिंग वीडियो। लाइक शेयर एंड सब्सक्राइब प्लीज़।